This is the largest solar thermal station in the United States, and it was built for this turkey meat plant, and the plant requires about 600 cubic meters of clean water every day with a temperature of about 60 degrees Celsius, and heating the water begins with these solar collectors which heat the water to a temperature of 30 or 50 degrees Celsius, and then the water is heated to 60 degrees by a propane boiler. In addition, the solar collectors heat these thermal storages during sunny hours, and their heat is consumed for the water heating in the evening and at night. This is a list of the main equipment of that solar station, and an expert can say that the construction cost of such station is about $5 million, and I predict that this station can produce this amount of heat per year if the average temperature of the fluid inside the collectors is 50 degrees Celsius. This video will tell you how to reduce the construction cost 9 times, and my solar station project will produce the same amount of heat, but its construction cost will be only $550,000. Firstly, we need to use these solar collectors which were described by another my video about 2 months ago, and its link is below. This is a list of materials of our solar collector, and we see that it is about $8 per square meter. But if we take into account the salaries of workers and other production and installation costs, the total construction cost is $20 per square meter. Unfortunately, our 1 square meter will produce less heat than 1 square meter of their expensive solar collectors, and this phenomenon is explained by the difference in the energy parameters, and these are the parameters for new and clean collectors. But my calculations of the heat production are based on these degraded parameters to account for dirt on the surface of solar collectors, their aging and other reasons for reducing their efficiency. So, we need to use more than 12,000 square meters of our collectors instead of almost 8,000 square meters of their expensive solar collectors. The second cause of reducing our construction cost is the use of this type of heat storage, but with a thermal insulation thickness of 5 or 10 centimeters, and link to the video describing this storage is below. Our solar collectors will heat the water of the storages during sunny hours, and the temperature of their water will fluctuate between 25 and 70 degrees Celsius. In addition, we must install plate heat exchangers, and they transfer heat from dirty water of the storages to the clean water which will heat to 680 degrees by the propane boiler. This is a list of expenses for our solar station, and we see that our idea has reduced its construction cost 9 times. This is our annual heat production, and it is equal to the heat production of that expensive solar station. Of course, our solar station will need a worker for maintenance of the solar collectors and other equipment, including for periodic washing of the surface of our solar collectors because rainwater does not remove 100% of dirt from the surface of this film. But we see that the meat plant is located in a non-industrial green region, and therefore a collector surface does not gather much dust, and besides, I remind you that the heat production calculations were based on these degraded energy parameters which correspond to dirty surface of our collectors. This is my calculation of the cost of heat from our cheap solar station, and it turns out that our solar heat is 3 times cheaper than heat from propane which is used by that American meat plant. And here I take into account the salary of that worker under the terms part-time work. I remind you that heat carrier of our solar collectors is water, not antifreeze, and the water moves within such polyethylene sleeves which are located between this steel sheet and the northern thermal insulation of the collector, and therefore the freezing of the water inside our collectors will not destroy them. But I must warn you that I have done too little technical testing of the freezing water inside my collector. In addition, we can avoid the freezing of the water through its automatic removal from the collectors in the evening, and this simple method was described in my old video about 2 months ago, but this opportunity is not needed for our solar station because it is located in a warm region where frost or snow is rare. Of course, we can use this simple scheme when this pump moves the water of this heat storage through our solar collectors during sunny hours, and this heat exchanger transfers the heat from the storage to the clean water which is used by that meat plant, but this more complex scheme will radically increase our heat production. So, we will have such heat production provided that we use this scheme with these 3 heat storages. The water of this heat storage moves through our collectors in the morning, but then they switch to heating the water of this storage, and then they heat the water of this warmest storage around noon. But our collectors will lose the ability to produce heat of this high temperature a few hours after the midday, and therefore they begin to heat the water of this storage, and then they heat this storage. These heat exchangers alternately transmit the heat of these three storages to the cold water which goes through this pipe, and we can notice that harmful substances of the water of our collectors and storages are not transferred to the clean water which will be used for the food production. Then this propane boiler heats the clean water to a temperature of 60 degrees Celsius, and obviously, it will be better to place our heat storage near the solar collectors, and the connection of our solar station with that meat plant will only be through this long pipe for the clean warm water. This is forecast of the heat production from 1 square meter of our solar collector during one absolutely sunny day, and this prediction method was described by one of my old videos 2 months ago. These are hours when our solar collectors heat the water of the coldest of our heat storages, and these are hours of the connection of the collectors with the hottest storage, and this is the temperature of the water inside our collectors. Let's compare this heat production with this case of the simple scheme, and this is its heat production when the water inside the collectors had this temperature. We can see that now this water temperature is noticeably higher, and therefore our heat production is 30% less compared to the case of this complex scheme with 3 heat storages. Unfortunately, this scheme is too complicated, and therefore it can be interesting only for a large solar station, while small solar stations should use this simple scheme. So, we know about a large number of different types of solar heaters which can produce very cheap solar heat, and my YouTube channel gradually finds them, tests and describe. This solar collector is not the best, but it meets the conditions of that American meat plant, and the conditions are the following. First, these solar collectors are designed for installation on the ground, however installation of a solar station on a horizontal roof recommends the use of such solar heaters which do not require damage to the roof waterproofing for their fixation against a strong wind. Interestingly, that meat plant has many horizontal roofs and vertical walls where other types of solar collectors can be installed. Secondly, these solar collectors may lose economic sense for cases of expensive land, and if its price is more than $1 million per hectare, we need to think about more efficient solar collectors. Third, the heating temperature is not high, and I remind you that my solar collector has a low efficiency if the water temperature is more than 70 or 80 degrees Celsius. Fourth, our solar collector may be interesting only for a very large solar station or for a company which plans to build many solar stations. If we want to build only one small solar station, this solar collector does not suit us because it requires investment in equipment for its production. A small solar station requires similar solar collectors which can be easily made with primitive tools. Interestingly, this solar station did not belong to that meat plant, but to this American company that sold the solar heat to the plant at a fixed price which is cheaper than heat from propane. And that American company planned to build a large number of similar solar stations for profit from the sale of solar heat.